Hello, everybody. My name is Elisa Baum, and I am Percona's Director of Product Marketing. We'll begin in just one moment, but first I'd like to conduct a bit of house cleaning. Would you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know that you can hear me? And let's take a look here. Great. I really appreciate that. That helps us. Okay, next, during this webinar, you will be on mute. Should you have any questions during the discussion, please enter them in the questions field within the GoToWebinar control panel. At the end of the webinar, we will take time to answer as many questions as possible. Those that aren't addressed will be answered in a follow-up blog post entry on Percona's MySQL performance blog. In addition, I'll make sure that each and every one of you has a recording to this webinar, as well as links to the slide within 48 hours. And with that said, I would like to thank you for attending today's webinar. MySQL High Availability and Geographical Disaster Recovery with Percona Replication Manager, presented by Percona's Principal Consultant, Yves Trudeau. And with that said, I'd like to turn the floor over to Yves. Yves, go ahead.
Thank you. So, hello everybody. So I'm here to introduce you to a way of achieving high availability with MySQL using PRM, the Percona Replication Manager, using in a geographical disaster recovery type setup. So here's my agenda. So first I'll cover the geographical disaster recovery problems and challenges. Next, I'll introduce you to a stack of open source softwares that can deliver the type of solution that we want. So I'll briefly introduce Corosync. I'll then switch to Pacemaker, Boot, and PRM. So for the one that doesn't know, PRM is a newly supported product by Percona. Support has been added recently, so if you have a support contract with us, I don't know which levels gives you what, but basically you can be supported on the Percona Replication Manager. Then I'll show you how to integrate all these technologies together to have a geographical disaster recovery type setup that allows failover to a remote site. Of course, it's not enough to talk. I'll give you a short demo on how that works in a simulated environment where I have 3 computers here that will act as VDCs running VMs, and we'll see how that works across them. So first, what are the challenges and problems with geographical disaster recovery? First big problem is the latency. Light of speed is finished, so there will always be a latency when you deal with a remote data center. There's other solutions that do geographical disaster recovery, Percona XRDB cluster is one. But the latency has a big impact on the write capacity of Percona XRDB cluster. So why not use, and for setups that are okay with normal MySQL replication, why not use normal replication for geographical disaster recovery? So that's what the PRM setup I'm discussing here will be covering. The other big challenges is to detect network partitioning. So if some sites are down or their internet connection is down, they won't be able to see the other side. How can we have meaningful failover behavior in such circumstances? There are solutions to that, and that's with Boot. And next question also is, how do we make sure that we have a single master? The setup I'm showing here, only one site will be a master at any given time, not both sites like with, for example, a XRDB cluster. That's another type of setup. So Next, what is Corosync? So basically, it's the communication layer within a site. So Pacemaker needs to synchronize information between nodes. Pacemaker is there for that. It's an implementation of the token protocol, which basically creates a token ring with membership and quorum. So in order to be able to put a message, you need a token, and in order for the message to be applied, it needs that a sufficient number of votes are available for that to be there. It's nothing specific to Pacemaker. It's an independent product that is used, for example, with Red Hat Cluster, and I think a few other projects are using it. It's really a generic communication layer. It's using UDP and multicast, but the newer versions can also do unicast. So if you're in a cloud environment that doesn't support multicast, you can still use it. It supports redundant rings, so if you have multiple networks, let's say a public and private, you could use both. So if somebody pull a plug, the cluster will still be able to talk. It's quite important. If you don't, a cluster that works well is a cluster that nodes can talk to each other easily. And of course, it supports encryptions, provided that you give an encryption key on all the nodes. So that's basically what Corosync is. Just review sample configuration file quickly. So secopt on is basically to enable encryption. The token is the token time. So here I have 2 seconds. It's in millisecond. The default value is 1,000. There's normally no reason to go above, let's say, 5,000. But if your network is flaky, you may need more than 2,000. VMs are especially known to have flaky networks, so be aware. If you're running in, let's say, VMware or VirtualBox or OpenStack, the token time should be raised a bit. But again, above 5 seconds, it's probably something serious. RP mode, that's the redundant ring protocol I just discussed. In my VirtualBox environment, I have only one network, so I'm not using it, so I set it to none. And then you need to define one interface per ring. So here it's very simple. Bind net address is where to bind the net mask. So if you're using a network address for bind net address, you have to provide the net mask. Or otherwise, you can specify the direct IP of the node. You specify a multicast address for a channel of discovery and a port for multicasting, for the communication to happen. The next component, the big one, is Pacemaker. Pacemaker is a distributed resource management framework. It's very powerful, has a lot of logic, and the brain itself is a specific process, the P engine, and the instance running on the DC, which is elected as the boss of the cluster, will trigger a series of events. Everything within Pacemaker is based on score. So if you want something to happen, it needs to have a high score. The configuration that has the highest scores will win and will be applied. You can define score for a lot of things, but basically it will always try to use the maximum score. In order to control resources, Pacemaker use resource agents, I'll discuss a bit later, that implements a set of commands like start, stop, monitor, promote, demote, notify, that are used to manage resource. Resources can be IP addresses, virtual IPs. MySQL is a resource, has a bunch of resources available. Boot would be a resource too. An important point, it generates events, and it synchronizes them. So let's say one of the things PRM is doing is we promote one of the master to one of the MySQL nodes, to a master role. And when it does that, after it sends a notification it waits for everybody to return from the notification state in order to move to the next step. So you can be sure, and PRM use that a lot, that at the given state, everybody is there and nobody is ahead doing something else. That's very important for data consistency. Pacemaker, I already said, has a rich logic. It has concepts of group, order, location, so a given resource running on a given server, co-location, two resources running together, a clone set, so identical resources running on multiple servers. Let's say you have a farm of attached servers, can be a clone, and a master state clone set. So it's a special type of clone set where one or many nodes can have different states. That's what we use with PRM. We have a clone set of MySQL resources, and one can be a master. What's very specific with Pacemaker is that the configuration, the SIB, is a living beast. There's no file for it. It's within the cluster. So there's a persistence set up with in some way, but basically the live one is only in memory. You need tools. You don't edit the file directly, except in exceptional case, like I will show you later. So it's really synced. You do a change. The change is so the command that does the change will return only when all the nodes that are available have applied it. That's a pretty interesting framework for that. So just quickly, a sample Pacemaker configuration. The first section covers the nodes. Usually you don't have to edit that section. It's created automatically by self-discovery. Next, you list primitives. Here, one of the primitive, there's only one primitive. It's a writer dip. That's just a name I chose for a very simple one. It's using the IP-ADDR2 script, which is a resource agent script, and it has two parameters, an IP value and a NIC. Those parameters will be passed by Pacemaker to the scripts as an environmental variable. And then we ask Pacemaker to monitor each 10 seconds if the resource is running as it's supposed to. So this is for the primitive. We then can add constraint, and here I'll just put one for fun, a location constraint that favors the right of it to be running on the node where the uname equal Pacemaker 2. So that gives, and I add a score of 10 for that. So it's not an infinite score, but it's a slightly higher score. So since here is the only score I have, it's very likely that if Pacemaker 2 is available, the right of it will be there. Finally, we have a property section. There's nothing very interesting there except the StoneIt enable, which is set to false because we don't have any StoneIt devices. StoneIt stands for shoot the other node in the head, so it's fencing. It's very important with any HA solution to have fencing. If a node is not able to perform an action, let's say here a node is completely frozen up, it has the VIP defined, so the kernel is still responding to that IP address, but let's say the disks are burning and the IP binary is not accessible to remove the VIP, there's no choice. The only way to remove that IP from the network is to kill the node, so you would need StoneIt in that case. Here, since it's only a demo, I don't have StoneIt devices, so I just put it to false. So it won't be bothering with StoneIt. So if you start such a cluster and look at the status, you'll see that, as we expected, the right of it is running on Pacemaker 2. That's just a very simple Pacemaker configuration and the way it works. We'll see in more detail in the demo how to interact with Pacemaker. So the next part, resource agents. Those are scripts. and most of them are simply bash scripts, but they can be written in Perl, Python, Ruby, name it, as long as you can read environmental variable and support actions, so parameters on the command lines. It has to implement some basic API, start, stop, monitor, metadata. Metadata is basically to tell Pacemaker what parameters it accepts and it needs. And optionally, for master slave clone set, it can have promote, demote, notify. So those are important. The MySQL PRM agent implements all these. Pacemaker, like I said, will pass the parameters. Like, again, in the right-of-it example, the IP address and the NIC were parameters. It will pass them to the script as environment variables. Pacemaker bases all its reactions and behavior on the return values the script will provide to the actions. So start, stop, if they failed or succeed, monitor if it's failing or succeed, or if it's returning that the current instance is a master or a slave. All that is controlled by return values. So there's a set of values that must be returned, and again, that's part of the API you have to follow. And it reacts to timeout. That's very tricky, because timeouts can happen if a server is swapping. So most of the evil you will have with a cluster, that's true for Pacemaker especially, but for other type of cluster too, it must not swap. If swaps occurs, timeout will be missed, and anything can happen. So it's very important in a Pacemaker cluster to first set for Linux, set swappiness to 0. Make sure that the dirty ratio is small, because the default values are just insanely high. And if you write a lot to disk and have fast writes, like SSDs, you could fill up the RAM with dirty buffers, and then can result in swapping. And also, of course, make sure that NUMA is set up correctly, and so that you minimize swapping. It's really the most evil thing that can happen. Okay, now we discussed Corosync, Pacemaker. Now we'll cover boot. What is boot doing here? It's to deal with the one partitioning issue that we had, that we introduced as a challenges for Geo-DR. It is an implementation of the Paxos protocol. There's a link here on Wikipedia. It's basically a token distribution framework with timeout. So what that means is that there's multiple phases, a bit like other protocol. It basically means that if a node has a token and is not able to renew it, it will expire and be available to be given on another node. It's very lightweight. I think while running on the VM, the daemon is using 5 meg. The bandwidth it uses, it's about, I think, 100 to 200 bytes per renewal. So it's very, very small. Sorry. See it in principle, it's quite similar in concept and principle with the DHCP protocol. So let's imagine you have one DHCP servers with only one IP and 2 clients. Let's say client 1 grabs the IP address first. It can renew it as long as it wants before the expiration, and it will keep it. But if it is shut down or disappear from the network, then the second client can grab the IP. So the token is exactly like that. It needs 3 sites for reliable behavior. 2 doesn't work, because if you lose one, the other one doesn't have quorum to establish that it is in the same state. So with 3 sites, that's considered 2 are database sites. With the third one can be a very lightweight cloud instance. Let's say for EC2, you could have a tiny EC2 instance, and that would be more than sufficient for running the boot daemon. So let's review quickly the boot life cycle. So assuming we have an initial cluster where the node 1 has the token, we have an arbitrator and node 2. What would happen is, let's say, communication between node 1 and node 2 is broken. Then there's no problem for node 1 to renew, because it can still talk to the arbitrator, and the arbitrator can register the vote and tell the result of the vote to node 2. So there's a tag there for the data. Something happens if the link between node 1 and the arbitrator is broken. Node 2 can relay the vote of node 1, and node 1 has no problem keeping the token on its side. But of course, if it loses both, the token will expire, and then the other two nodes will realize, oh, the token has expired, and has not been renewed. So let's grant it. And since the arbitrator is basically boot daemon running in a mode that it cannot grab the token, and it will end up on node 2, which is what happened here. So now we discuss boot, discuss Pacemaker. How do they integrate together? So the boot daemon, there's a typo here, runs as a Pacemaker resource. So Pacemaker itself will start boot on and make sure it runs on one of the server. It will be accessible through a virtual IP dedicated to boot. Okay, it's just for information, this PRM is now available as for Gold and Platinum contract support. So what the boot daemon will do after that, it sets an attribute within the SID that allows Pacemaker to react on the presence or not of the token. So it's really, we will build some piece of logic around it. So if the token is there, you can be a master and be promoted. But if it cannot, and you are a master, you have to be demoted. And then that will control the attribution of the master role on a given site. So that pushes me to introduce now the basic of how PRM works. I already covered that into some presentation I made to Percona and a webinar I gave many months ago, but I will just review it quickly. What PRM does, it starts and stops MySQL. It's a resource agent for MySQL. It also manages replication. It means you don't have to do change master. It will do it automatically for you. It monitors MySQL, and especially for the slaves, it adjusts the reader VIPs according to the state of replication. So if replication is not in the same state, it's lagging too much, or replication is broken, it will remove the reader VIP from these slaves in order that the application doesn't see stale data. Another point, if a master crash, it will try to restart in place at least once. There's a window of time, and within that window of time, it will try to restart one time the master. If it crashes again, it would be the service would be moved elsewhere. But here it's quite important, because if the master has transactions that have not been sent to the slave, it's important to try to recover as much data as we can. And restarting the master in place is the best way to ensure that. But we don't want to be stuck into a situation where the master crashes all the time. So the window of time is defined as 5 minutes. So within 5 minutes, if the master crashes twice, another node will be promoted master. So right now, the master promotion is based on a score which is basically a constant minus the slave lag. The most up-to-date slave is promoted. So if there's a slave with no lag and a slave lagging by a few minutes, the slave with no lag has a higher score, so it will be promoted as a master in the event of a master crash, of course. If the operation is clean, it's just a clean demote and promote, the way it works, all the slaves will be allowed to complete the download of the binary logs and the application of the relay logs within a given timeout. This setup is also perfectly compatible with semi-sync replication, so that could also help not losing any bits of data. PRM is still under development. I'm spending time adding features. There's a few features that are already developed, but not fully tested and stressed. I'm changing the master score, the way it is based. Right now it's on the slave lag. I want it to be on the difference between the master position and where the slave had, and the amount where the slave had executed from the master. This will be much more precise, because right now two slaves can be at 0 lag, but one has, let's say, 20 transactions more done than the previous one that has not been able to download before the master crashed. So in that case, we may be missing 20 transactions if the wrong node is promoted. That way of calculating the score will solve that. It is already coded. It's in the GitHub. I just need to finish my test, which I should do soon after the webinar. Another thing that has been developed by one of my colleagues is the support for 5.6 GTID. So it seems to work very nice, very clean the way it is implemented. So again, I need to just complete the test and release it. That will allow exactly the same type of setup, even with Geo-DR and with GTID. And what is fun is that since GTID will resynchronize all the missing transactions, it solves a lot of problems at the same time. Finally, something coming probably more at the beginning of the winter, I'll implement a way for the slaves to come back and sync together after a master crash. So the most up-to-date slave will publish a list of MD5 hash of the binlog payload along with the binlog file and position for the last few minutes before the crash of the master. And then all the slaves that will need to repoint to the new master will look at their relay log and find the MD5 hash of the last relay log transaction that they played. And based on the hash they found, they will query the newly promoted master and find where they should start, which will not necessarily be the last transaction published in the show master status. So it will allow them to resync into an interesting way. And what's good here is that it doesn't imply any non-MySQL communication. It's done in a distributed way on all of the nodes at the same time. So it's I have the working example, all of this. If you do it by hand, now I need just code it inside the agent itself for support. So let's review quickly again the how PRM works. So I have 3 nodes. So Pacemaker is not started. We start Pacemaker. It promotes its part MySQL on the 3 nodes, and let's assume here it promoted node 1 as the master. So node 1 is promoted. Part of the promotion process is to publish the replication info data. So if this is published to the SIB, so all the nodes have it, which includes the current node being the master, the binlog file, and position. It becomes read-write, so it allows us to have the write of it and the reader VIPs are first defined only on the master. Then the next step would be to notify the slaves that there's a new master. So the slaves will query the SID, find out that node 1 is the master, and that the bin log file is 1, 2, 3, and position 3, 4, 5, 6, 7. So they will issue the change master and start slaving out node 1. And if replication is in the same state, the reader VIP will will be distributed to these slaves. What happened is the node crash, the master crash. So here we assume that node 2 is the most up-to-date node, and node 3 was lagging slightly. So that means node 2 would be promoted master. So it's part of the same process, part of the promotion process. We'll publish into the SID the replication info, telling that now it's node 2, the bin log file has changed to 145, and position also changed. It will start a VIP. The VIP will all move to node 2, and then after that, there will be a notification of a new master, and node 3 will, like before, query the SID, figure out that now it's node 2, and connect to node 2, act as a slave, and be able to be running a virtual IP for the reads. When node 1 is back, assuming that no data has been lost and it is in the same state, it will query the SID, see that, oh, I'm no longer the master, so we'll just change master to node 2 and behave as a normal slave. So that's the principle behind PRM. So now we will add a layer of geographical disaster recovery to it. That means I'll be considering 3 sites, 3 locations. Site 1 and Site 2 are fully functional Pacemaker PRM clusters. By fully functional cluster, I mean it could even be a single node, as crazy as that. You could have, it will work as a single node cluster. So if you just want to have disaster recovery and your remote site, you don't have to have many hosts there, it will work with only one. As long as it's trying PRM, Corosync doesn't make any sense there, but it has to be there. So, but it will work. Again, the arbitrator site can be anywhere except on those 2 sites, and is very light. What's important? The setup prioritize local failover. So as long as there's a node available on a site to be the master, it will use that node for the master. Only when it has exhausted all the options that it will fail over to the other site. Of course, it could also lose the token. If the token expires, it will switch over. Another important point, only one site is writable. So if you need to connect to the remote site for write, the application must be able to do that. It's on the topic here. It's possible to have a resource that redirect the traffic. It's also possible to run with HA proxy. There's many ways of doing this, but there will be only one master available at any given time. So let's just review the way this works. We have the 3 sites. The arbitrator is site 3, site 1 and site 2, 2 nodes each. Site 1 has the token, the small yellow ring there. There's one master in site 1. All the other servers are slave of that node. What happens if it dies? Simply Corosync, PRM on site 1 will promote the other server to be the master, and the servers in site 2 will discover there's a new master and reconnect to the new one. But if we lose both servers, there's no longer any servers able to run with to be the master. The token will expire, so it's important to define a token time that makes sense. If you set it to 10 hours, yeah, it could take 10 hours for a failover, which would be a bit crazy. So then site 2 and 3 will elect a new site to be to have the token. Site 3 cannot have it, so it will be site 2. And site 2 will promote a master, and the remaining server will be a slave of that master. So in the demo I will be presenting, there's the 3 sites. So site 1 has a network 10.3.1.0/24. The 2 nodes there would be Pacemaker 1.1 and 1.2 on IP 1.1 and 1.2. The boot VIP, where to connect to boot, would be 1.10. The writer VIP would be 1.20, and reader VIPs .21 and .22. It's about the same thing on site 2, except the network is 10.3.2 instead. All the other offsets are the exact same. And site 3 will be 10.3.3.1. So, like I said, the prerequisite for that setup to work: 2 PRM clusters working, site 1 and 2, identical MySQL data set, so all the nodes have the same data set. The MySQL grants are adjusted for cross-site replication, so any node can be a slave of any other server without any grant problem. The one is open for SSH, MySQL, and boot. So port 22 TCP, 3306 TCP, and boot by default use 6666 UDP. SSH is configured, and the boot packages are installed. Let's review these 2 quickly. PRM use root as a user by default. It could be any member of the HA cluster group, but it's not coded that way, but it's super easy to change. And it must be key-based, so it will not do the chatting to enter the password. It must go straight through with keys. So all the nodes from site 1 to site 2 and vice versa must be able to SSH. You must tune the SSH daemon configuration so that it is quick or it has to time out. So make sure that the ciphers are well aligned. There's has been a long issues between Ubuntu and CentOS Red Hat, where the cipher order was not the same, and it could take many iterations to finally agree on a cipher. So make sure that when you SSH on the same day where the network has no problem, it is quick. If it always takes many seconds, that will lead into problems. Also, define a timeout. I already told you that Pacemaker reacts to timeout, so it's much better that SSH timeout and the agent is able to trap this and react in a sane way than to have the agent timeout, where Pacemaker will go crazy. So I usually put in the .ssh directory the config file there. I put entries like this. So all my nodes are on the 10.3 network. So I put connect timeout equal 2. So if after 2 seconds I've not been able to connect to the remote host, I just time out. Very important. And I don't want to have issues with having to accept a host key, so I disable strict host key checking. The other small prerequisite we need is to have the boot packages. On recent Ubuntu and Debian, that's really trivial. You just add get install boot and boot Pacemaker. But on EL6, it's not as simple because there's no RPM. So either you go to the Git repo of the maintainer and copy the source file, compile, and all that, or I provide a boot RPM that works. It's in the reference section, so basically you have to install this RPM and everything is fine. Okay, now that we have boot, we need to configure it on all 3 servers. So the boot configuration, I changed the timeout because I was tired of waiting 2 minutes in my demo. So basically, what you have in boot configuration file is a transport, UDP, a port, which node is the arbitrator, and which node are sites. So for the site, we use the boot IP, the boot virtual IP that we already discussed. And finally, we define a ticket. The ticket will be the entity that is passed between sites. It has a name, ticket master, and a timeout value. I changed my configuration for 30 seconds. This one has 120. In real life, 120 makes more sense. 30 seconds is short. But in the demo, since we'll have to wait for failover, I don't like to be silent for 100 seconds. So I lower that to 30 seconds. On the arbitrator, Pacemaker is not running, so make sure the boot didn't start automatically. So either with check config or the upstart service and Ubuntu Debian. And then, okay, we have it's configured. We need to tell Pacemaker on both database sites to start boot, basically. So there's a boot resource agent, boot site. So we define a primitive. We define a primitive also for the boot IP, which for the site we'll be working on will be 10.3.1.10. We group those 2 resources together. So the boot IP must be present on the node that is running boot so that boot can be reached. And for sanity, we add an ordering so that the boot daemon, the boot group, must be started before we attempt to promote MySQL. That will basically prevent a promotion in a situation where there's no, the ticket has not been granted yet. And finally, not finally, there's another step after. We must inform Pacemaker of the constraint linking the mastership role with the presence of the boot ticket. So if you're running a recent version of Pacemaker, the user space tool, not the user space, the time tool is able to understand the resource ticket constraint. So you just write it like this. It basically tells that ticket master and MS MySQL the role master of that master slave clone set are linked together, and if the ticket is lost, you have a demotion. If you're using an older version, which is very common, so that's why I'm including it, and I'll give the example how to deal with this because for in purpose my demo is using 1.1.7. So you need to edit the XML file. So I told you that it is a living configuration, but if you pause, Pacemaker can download can write the configuration to an XML file and reload it. So you need to add the constraint by hand. You normally would never have to do this, but it's a very special case because basically Pacemaker, starting from 1.1.6, understand the resource ticket, but the tool to edit has not been updated until 1.1.10 because it's not the same maintainers. So we'll have to do this second version here. And the very final step, we must inform PRM that it is in Geo-DR type setup. This is done by adding 2 parameters to the primitive declaration. One is the geo remote IP, which basically tell the agent if you want to see what's happening on the remote network, connect to this IP over SSH and query. And if you want to check if you're the master, look if you have the ticket master. So that's basically to determine if a site is a master position and react accordingly. So we've done a lot of talking. Let's move and run a demo of this. So let's see here. Okay, I cheated a bit. So I have the three sites. So site 1 is those 2 servers here. So site 1 is running normal PRM. There's nothing specific here. So there's a master and a slave. I pre-configured slave the site 2 as a Geo-DR, but since there's no partner, it's not doing much. So this one has only slaves, and it's basically waiting for something to happen. And of course, I have here the arbitrator. So if I just show you pipe-grep boot, the arbitrator is currently running and taking about 5 mega RAM. So it's very small. Okay, so let's do. So the first thing we must do here is to add the boot configuration. Oh wait, first I'll show you the current configuration, which is the regular PRM configuration. So like that. I'm using cat because the way it works was to try to put colors and not necessarily good. So again, at the node section here, the primitive for PRM with all the settings, socket, user, and all that. The monitor ops for master and for slave. The start and stop timeouts, which are important. Primitive for the VIPs, so 2 reader VIPs and 1 writer VIP. The definition of the master-slave clone set. We have 2 nodes, so maximum number of clone is 2. Using notification, very important. Next, we define the rules to lock the reader VIPs, set the behavior, of the reader VIP based on replication. So the agent will change the readable attribute. When the state is in a good state, it will be 1. And when it's not in a good state, it will be 0. So that basically put an infinity, and then the score will be infinitely low that the reader VIP runs on a node that has readable set to 0, so it will move away. Also, what else? Collocation rules. I want the VIP to repel, so they don't stay on the same node if there's another option. I co-locate the writer VIP, so there's an infinity here, with the master role. So the writer VIP will be tied to the master. Then I want the promotion to happen before the writer VIP ever exists. Upon demotion, it will stop the writer VIP before it demotes. That's all for sanity. And here we have, of course, the Stonenet enable set to false. And since we have a master, it has published its master information. So it's Pacemaker 1 that is the master. So now we want to turn this into a boot type setup. So first boot, we ask Pacemaker to become a boot to load and start boot. So do this, run configure load update testing. Those timeouts are normal. Okay, let's see what we have now. Status. So boot is running on Pacemaker 1.2. So everything is good. The next step is to define the new primitive. So I'll go here. Well, wait a minute. I'll just show you what's in the file. So basically, the only thing I'm adding is these two settings here. So that's very simple. Done. Finally, I must add the constraint for the ticket, and I'm running 1.1.7, but I must do it the long way. So first thing, I will put the node in standby. So, okay, I'll stop. I'll download the SID to a local file. I'll edit it. That has to be into the constraint section. The higher tip. Okay. So read 3 star. Yes. Okay. So now from local file, I need just to apply. So I reload it, and I put the nodes back online. So right now there should be no masters. So let's just move here to be quicker. Okay, so that's the other node showing the cluster status. MySQL is started on both, but in a slave state. Basically meaning there's no masters, and doesn't mean that they are really slaves, just that they are not promoted. So we need to initiate to give the token. So I'll move to the arbitrator and give the token. So revoke grant. So I'm granting the token to the boot that is at .1.10, which is Pacemaker, the first site. Giving the token. Let's see here. So it has already promoted the master. And Pacemaker 2, the node I'm on, is a slave. I created a shortcut for show slave status. So it's Pacemaker 1 that is the master. Let's see on the other node. So still running as slaves. But this time they should have noticed that, oh, there's a new master, and should have react. So let's see this one. So it's replicating from Pacemaker 1-1, and this one is also replicating. So they configure themselves correctly. So what I will do now, I'll put the master in standby. So standby, so it will no longer be running. So PRM will promote Pacemaker 1-2 as a master. So it is now the master. And let's see that the other ones have followed. So if I look here, it followed. How's it doing? Okay, I think I know why. The virtual IP changed and it got the ARP cache was not updated on the VM. It should not be on. That's the kind of thing that can happen. So now it's replicating correctly. Now, what happens if we stop both nodes? So here, some none, so we're no longer running. Go to the arbitrator, let's see, list. Token will expire at 55, so in a few seconds. Okay, that expired. So now it's 2.10 that has the token. Let's move here, see who's the master. So it's -2-2 is a monitor failure here. It's not a big deal. That's just before, because of the bit problems that we had. So if I look here, this guy is master, so there's no slave status, and this one is not a slave. And of course, now the write of it is defined on that side, and the read of it are all there, spread on the two nodes. So that's the demo. Just for references, if you want to build a PRM, there's a setup document available on GitHub. I try to maintain it with the new features. It may still lag a bit behind, but not much. There's an operational guide, so to do things like if you want to do extra backup, if you want to add nodes, remove nodes, and things like that. There's a Geo-DR guide that basically recaps what we have just seen in a more document way. And of course, there are two mailing lists, PRM Discuss and PRM Devo, that can be used if you have any questions. I'm responding to emails there as soon as I can. And of course, if you need to run boot on EL6 and want to download, the download link is here. There's a 32-bit version if you need to run it on a 32-bit host, like let's say low-power cloud instance. That's it. So if you have any questions, feel free to ask.
Hello. Thank you so much for asking. We only have a few minutes left, so I will make sure to keep the questions window open even after the webinar is closed. I'll leave the questions open. Just wanted to let everyone know, because there's been several questions, that PRM is now supported with the Percona Gold or Platinum support contract, and our website has been updated with this information. So if you go there, you can take a look and get more details. All right. Sorry, Yves, we have just a few questions here. And then, like I said, what we don't get to, Yves will write a follow-up blog post and make sure to address your questions. And also, please remember that I will send you the recording to this webinar as well as the slides. So you will have that in your hands within 48 hours. Okay, so the first question I have is, you indicated that PRM is working with GTIDs in 5.6, and the question is, will this be available from GitHub soon?
It is already available, but it's not in the main branch. So if you go to the GitHub, you can. Sorry. It's available on Fred GitHub. Yes, I will send it soon. I don't know exactly when, but should be very soon. So it will be a distinct agent. Instead of MySQL underscore PRM, it will be MySQL underscore PRM 5.6. And it will be, I mean, it's working very nicely. Because of the preparation of the webinar, I had to devote a lot of time to the webinar preparation. I did more than a few basic failover with it. So I need to run the test, and then I will just publish it. So it should be before Christmas for sure. Is there other questions?
Oh, sorry, I was on mute there. Go ahead and keep typing them in. We have time for one more, and then Eve will answer these for you guys in a follow-up blog post. So the next question is, does PRM do anything different with replication over the built-in MySQL replication to combat the single-threaded nature?
No, it does not.
Okay.
We don't go beyond that.
All right then.
It's just a wrapper around replication.
Okay. Well, this brings us to the top of the hour. Again, I will keep this questions window open for as long as anybody would like to ask them. And thank you so very much, Eve, for today's webinar. It was great. Love the demo. And everybody, thank you so much for attending. We really appreciate your interest in our topics. We have quite a robust webinar schedule that is being updated as we speak all the way through February. So take a look at that, and we'd love to see you on these future shows. Again, thank you all very much, and I hope that you have a wonderful morning, day, or evening, depending on where you're dialing in from. Eve, thank you again.
You're welcome.